So today was Find Cool Rocks Day, and I put a little bit of spray shellac on there. It's my favorite thing because that way I don't have to dunk it in water to see what's in there, right? And this is a piece of fire agate. And I believe that this one came from Safford. This came from a friend who was the UPS driver in Safford, Arizona. And he collected this himself. Once upon a time, I, I I figured out this thing about the Fibonacci sequence, and I started investigating it. And one of the numbers is 144, which is also 12 squared, and it's the 12th Fibonacci number. Hmm? So I thought, there's a magic number for sure. And out of 100 tries, I won this on one of those guess a number games, and I don't think that he actually did a drawing. I never saw him do a drawing. I think he just liked the number. Because he knew who I was. I mean, we were friends, right? We'd been friends for a long time. So he drew my number. And he sent me this. And here it is. And it's way cool. When I bought it, I had every intention of keeping it just like this forever and ever. I didn't buy it, right? I mean, won it. And I got this thing, right? This is what they call bacon fat. And the fire agate is actually down inside of here. And you got to remove it. And another very, very, very good friend of mine, Wendell Thatcher, also from Safford, Arizona, more or less, um, told me he was the master of fire agate when I met him. And he would take this stuff and remove this stuff and work down to these little botryoidal bumps, um, and get just incredible shapes and colors and stuff out of it. Um, and he told me when I was over there one time that he found two different hardnesses in fire agate. I thought that's I mean if it's quartz, it's 7 on the Mohs scale of hardness. It's one of those invariants. Because it's not like magic. It's not something that's a variable. It has to do with the 4 oxygens around a single silicon atom, and that makes silica. Okay, and silica is um, silicon dioxide, but those four oxygens around it share their electrons with silicon atoms next to them. So it goes silicon oxygen, bump, 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 bump. Um, and except they do it in chains, right? They form them like spirals, kind of like this, bump, 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 and see that'll keep going. Those bumps are part of that, and they're showing you the crystal structure, right? Um, and if there is any, and what we have here, I think, is maybe something that was exposed to high heat twice, covered with volcanic ash a second time, and once again exposed to high heat. And along these layers where the stuff forms, the little botryoidal bumps, the layers are half the size of a wavelength of visible light, right? It's just one of those layers. And the light goes down half a wavelength and bounces back off half a wavelength, and that adds up to a whole wavelength of visible light. And that causes what's called thin film diffraction, like oil, right? Oil slick on a puddle. It's the thickness of the oil that creates those patterns. It's like interference patterns or something almost, but it's because the thickness of the oil varies, and usually like in a very regular manner. Okay, so what we've got is something that's botryoidal, but it's forms in kind of spirals and stuff. Um, and it looks melted because it is. It's supposed to be quartz. It's 10 on the Mohs scale of hardness. It's not two hardnesses at all. I mean, this stuff might be something else. And what you're seeing is the matrix that it came from, um, and kind of the layers are already there, just simply because that's the way this other stuff collected, and what this is AUPT, gold platinum alloy, and it's kind of goldish colored because, but it's mostly platinum. That's why this is kind of whiter. But there's enough gold in there that it forms double covalent bonds, and covalent bonds are exclusive of all else. They don't share electrons like metallic bonds do. Okay, so they don't pass electricity. Room temperature superconductors with 10 on the Mohs scale of hardness pass magnetic fields without resistance. And they're really cool too. I mean, look inside of here. Look at this. Is that awesome? And so my spray shellac means I don't have to polish it to look inside of it. I can look at the whole thing. And as that dries, I just put it on an hour ago or so. As it dries, it gets less shiny. But mostly what you're seeing is the shininess of metallic reflection, and that's part of the photoelectric effect. When light, a magnetic wave, interacts with a metal, the metal atoms go up one notch in energy. And if it's an opaque thing, like has metallic bonds, um, the it can't stay up at that higher energy level. Metallic bonds just share one electron at a time with their neighbors, and that's why you can bend them and deform them with a hammer and make them into things. And they pass electricity because they're sharing those electrons with their neighbors. Um, Covalent bonds don't do that. But those double covalent bonds are sharing two electrons with each one. And carbon and silica have 4 electrons in their outer valence orbit, both of them. Gold and platinum are next door to each other in the periodic table. They're different metals, And what they do is they line up in north and south orientation in cubes. And those cubes have 13 atoms, and they can be all gold, all um, platinum, and then they'll make these little 13 cube atoms, or they can vary to like a 50-50 mix. It's called a solid solution series. So they look different in different places. I have other AUPT that is, let's see, right here by my feet. That looks very goldy colored, and it's shiny, and it's really, 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 really heavy. So is this. So is this. Because it's platinum and gold that got melted. And they have double covalent bonds. Double covalent bonds. And you can't scratch them with a diamond. In case you never saw a real diamond, here we'll take I gotta lower the magnification a little bit. My diamonds are not like De Beers diamonds. They are rather larger. You don't need magnification to see them. Okay, but what you see is a cube, right? And part of a cube. You knock off the top of it, but that's what it is. And this is called the Asher cut. And it really accentuates the cubic nature of the crystal, because what we're doing is looking down the z-axis here. We've got an x and a y, making an x there, and we see reflections off of the bottom, not not anything else, because the light's behind me. How about that? It is the most clear substance on Earth. Think about how thick that is, and it's got hemp seed oil all over it, and other things. I spray bug spray around here, and this has been kicking around down on my floor. Apparently, my wife brought it back, and you notice it's unscathed from its experience, and that's because you can't scratch them in any normal sort of a way. You can gouge them or break them or something, and you can split them in half if you know how to cut them just right, and some people do. Some people do. This is I think from Longwen in Kowloon, China, or possibly from Asher Diamonds and Gems in Thailand, in Bangkok, Thailand. And Asher, I think, is the guy who developed this cut. But he's working now. The stuff I buy from him now is cut by a machine. And I don't think this is machine cut. This is hand done. It's a beauty. It is a real beauty. And I have a bunch of these. I think I paid about maybe $10 for them, something like that. Nice. Because see, diamond's not rare and it's not scarce. It forms on every fault line on Earth. Rivers and creeks, dry washes are fault lines. All of them. Every single one of them. And they are about 50 kilometers deeper than the deepest kimberlite pipe. Because they go all the way to the molten mantle. And sometimes what melts these things is subsequent volcanic activity. So when I say it got melted, that may be what happened. because after the KT extinction event, all this volcanic ash, and that's what this stuff is. It's volcanic ash, and it settles in layers, and because it's AUPT, it also orients itself north and south with gold, platinum, gold, platinum in kind of a three-dimensional checkerboard. You can actually see it when you really blow it up. I would have to get closer, but you could see it. And they do that to automatically. You don't have to do anything. They just do it all by themselves. Um, and this is a crystal of carbon. Okay? And I bought it as, I think I bought a kilo of them as quartz crystals. People like to carry them around and put them on their dressers and stuff. And they think they're magic. They're magic. And they do all these cool things. And they do, actually, because they're not quartz. Quartz does not have planes of cleavage. Does not form in cubes. Quartz can't have planes of cleavage. It forms in spirals, right? And I haven't actually found any. I've been looking for some, man. And that's what I thought this was, right? Fire agate. It's not. It's gold platinum alloy that's been melted. Maybe in subsequent volcanic activity, maybe in the KT extinction event itself. I don't know. I certainly don't know. But I'm going to find out. Look at that. Isn't that awesome, man? I mean, that is really, truly awesome. Look up inside of there. So, and those are planes of cleavage. And planes of cleavage happen. Gold and platinum are about the same size, right? They're 78 and 79 in the periodic table. So 78 protons and 79 protons and various neutrons. Gold has no radioactive isotopes. Platinum, on the other hand, does. Some of what you're seeing there is radioactivity. And my friends that mine this stuff have been dying like flies. I'm 67, and the woman I used to cut black opal for died of some form of cancer. My best friend Wendell died of some form of cancer. I've got little radioactive blips in my thumb and fingers from handling these damn things without gloves and proper equipment for radioactive sources. My father taught reactor physics when I was in high school, and I learned quite a lot from him. And that's probably why I recognize what we're looking at here. That blue glow is a little bit of radioactivity from the decay of uranium, or from the emissions of probably more likely thorium, right? This light blue thorium. When I find things with dark blue and purple, then you're looking at some inclusion of uranium. It is ubiquitous in the environment in the western United States because the entire surface of the planet was exposed to like a nuclear holocaust type event, the entire planet in the KT extinction event. There was a civilization prior to our own, and they were fighting with somebody from somewhere else. They thought they had the largest ship in the world, and they were using a weapon as force and coercion on other people. And so now the people, what I'm told, is that the people of our galaxy asked the Emperor, and the Emperor is like, he runs a bunch of galaxies, I'm told. That's what I think. And he's very, 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 very old. And he doesn't, it's just a guy, he's not a god, right? Just a guy. And I'm also told that his goal is not to run your life and take your stuff, kind of just the opposite. He wants to provide an umbrella under which freedom exists. And the stuff, this gold platinum alloy, it's a room temperature superconductor. This is what makes spaceships go. Hmm? Yeah, it makes spaceships go. Because you can travel the stars. And some people can travel galaxies. And the benevolent government of planet Earth back then, I think it was about 35,000 years ago, not like millions of years ago. Because of the radioactivity it left behind, okay? And that's why I think that. It's still really fresh. It's not like worn out. Because like when uranium starts breaking down, and it does, it just does it all by itself. You don't have to blow it up to make it fission. And it fissions at a very regular rate, and we know what that rate is. So you can measure it because it's really long time for the half-life. Half of it turns into thorium in something like 1 billion years or something. It's a long time. And it may be longer. I'd look it up. Some of them I know, like Pu-244, plutonium, which gives off a red color because it's only beta particles. It's not alpha particles, and so they're lower energy. They're smaller. And you could, like, the radiation doesn't go far, right? I can hold my thumb to it, and if I left it there for a couple of years, I'd have something like that, right? But you can hold it in your hand. It's about as dangerous as old-fashioned television sets, right? That's what they used. These are electrons, beta particles. And beta particles travel at the speed of light. Okay? They have mass. So they're a form of radioactive energy, but it's actually not getting smaller things like thorium, the smaller than uranium. It makes larger things. And so that's how we make uranium into plutonium. And it turns out that like the mountains behind me with all this aluminum oxide make plutonium-244. And they're basement rocks, right? They formed deep, 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 deep in the earth. But I think somebody did it because it's a natural breeder reactor. And there's like what looks like a door on the top of one of the mountains, and and other things. There's some kind of secret installations up there that you can't even see unless you look in satellite photos. So anyway, this is interesting stuff, and it's very heavy and very hard because it's 10 on the Mohs scale of hardness because it's got double covalent bonds, and it, like diamonds, won't wear out. You can machine it. You don't have to make it into jewelry, right? You can make it into any damn thing you want to. And it's not scarce at all. People call it quartz, right? That's what people call quartz. It's called chalcedony. And that's what chalcedony is supposed to be. But, of course, whoever started doing that, telling people that, didn't actually measure it, right? So when you actually measure it, like I do, you find out it can't be quartz, because quartz is only 7 on the Mohs scale of hardness. Because it's only got a single covalent bond, or a double covalent, right? It shares an oxygen with 4 atoms of, no, 4 atoms of oxygen share their electrons with a silicon atom on either side. So it's silicon dioxide, the 2 atoms, 1 with each one, though, right? So they're not really very strong. They're not as strong as this, because these are shared across a 13 atom unit cell. And those unit cells are bound together in a cubic hexagonal, face-centered cubic hexagonal arrangement, and you can't get any closer together. You can't make things get closer together. And I don't know about you, but I mean, these things make pictures. They're like a 3-dimensional image of things, and the more things they put in, the better, the cooler they thought it was. It's like multiple entendres are the rule rather than the exception, and you'll find all kinds of cool stuff. Somewhere here there's some sort of face. You've got one eye there, and kind of a crown, and that's the emperor. Starfire family, maybe. See, he came and wiped out the people of planet Earth, not because the people did anything wrong, but the assumption of they did a conclave with peoples from all over the galaxy, and they met and talked for a long time. And it was decided that we, the people, are responsible for our benevolent government, not, my friends, the other way around. And when you have benevolent governments, they do not bring peace and prosperity. Benevolent government requires your taxes to exist. It confiscates those taxes by force. And you know what? They didn't tell us about AUPT. They didn't tell us that there were other people on. And they fed us more or less like mushrooms, right? They fed us bullshit and kept us in the dark.